So hi everybody, let's go for a new video tutorial. So today we will see how to enter expression data in mutant condition. For example, an experiment with a morpholino, chemical inhibitors. So I will take another article for this example. I will take the article from ANISEED because the last article I took for the tutorial didn't describe this kind of experiment. So here, for example, I want to enter the figure number 2, evidence with a chemical inhibitor here. So let's imagine that we already created the article card. So I go to search for article, put Agnès Roure, and go to the article card. I already enter some data, for example, and I would like to continue to enter data from this article. So I want to enter data I want to enter gene whose regulation was studied. So I enter MS6P, KLF, and KH.C7.391. I enter this gene. Okay. And yes, this one. And I save data. Okay. And now I would like to enter the first experiment for MS6P, so I click on the link under experimental evidence. Here that I have 0 results, which is normal because I didn't yet enter this evidence. I first created the experimental context, so the method of analysis, in situ hybridization, and a general comment of the evidence, so expression of early and late of early, sorry, B6.5 lineage, marker when FGF, ERK and nodal signaling pathway are disrupted. Signaling pathways are disrupted. Yes. Okay. I select the animal provider, the species, the stage. So this is the same method as the entry of wild type expression pattern that you can see in the video number 2. So everything is the same. I want to add an expression for the wild type expression pattern for the control embryo. So here I show the author here, Agnès, select a probe. So here the list of clone. So the clone, I retrieved this information in the article in the material and method. I had the picture. Yes. So this is only a screenshot from the PDF file. And I enter a comment to the image. And here I can add animal view of MS6P at gastrula stage, and I put what I call original comment, original annotation from the paper, MSXP is expressed in the 4 daughter cells of the P6.5 blastomer. So this is from the paper. I retrieved this sentence from the paper. Okay, and the substrate. The territory of expression, so which is P8.17.18, 19, 20. So I search in the anatomical tree the corresponding territories, and yes, this one. Okay, and I submit my data, and I can save my control embryo. Okay, perfect. So my wild type embryo is here with different features I enter. Now I want to enter the mutant biomaterial. So first I will describe what we did on this embryo. So I cannot choose. I can remove the species, which is normal because we work on cyanintestinalis on control, so it's the same on perturbation. So here first we have to enter the molecular tool that we'll use for the experiment, and after from the stage we use the molecular tool to the end of to the stage of the analysis. So I enter my molecular tool, and if it is already entered in the database, it will appear. So I click on it, I choose the stage, so click on select, choose stage, so it was from 8 cell stage, submit, and the stage of analysis, early gastrulate stage. Okay, and I submit my data. So okay, I have my mutant biomaterial now, and I want to add expression to this mutant. So click on add an expression, and here I retrieve the same page to enter expression data. So I enter my probe, I had picture, it was figure, yes, this one, same, I had a comment. So here, this is also an animal view of MS6P at early gastrulate stage. Yes. And the embryo was treated with the MEK inhibitor. Yes. And here also I will add the annotation, what the authors say in the paper. They say that there is no expression. of the B6.5 Estonian. Okay. And the substrate, the territories of expression. So here no expression, submit data, and save. Okay. So here you will have also the summary of your mutant embryo, and you want to enter the last figure. So this one, yep. And for that, you click again on Add a Mutant Biomaterial. You will create a new mutant biomaterial with a new experimental perturbation with another molecular tool. So here SP431542, which is already in the database. You select the stage of perturbation, the stage of analysis. Yep, you save, and you will have here the summary of your second biomaterial. And you add also the corresponding expression, so you click on Add an expression. Okay, you select your probe, which is the same. Tac. You add picture. Which is this one. Yep. You add a comment, so in the same manner and as previously, animal view. Here, the original annotation from the paper. Yep. The substrate and territory of expression. No expression. You save the data. and you have the summary of the evidence. So just now, let's imagine that you didn't, the molecular tool you want to enter is not already present in the database. So here, for example, you search for the test molecular tool and there is no results. So for that, you have to create a new molecular tool. So you just follow the page, you put the species, the name, the type of the molecular tool. So here, let's continue with inhibitor. You can put the supplier if you know, but it's not mandatory. The type of regulation, if it is a loss or gain of function. Here you can put a comment. So for example, molecular tool that disrupt the gene X pathway. You can put also the sequence, so sequence of morpholino, TALEN. For TALEN, you need to put two sequences. You can put it as a FASTA file. PubMed ID. So here it's the PubMed ID where you can find the molecular tool. So you can add more PubMed ID if needed, and the target gene of the molecular tool. So here, let's put the first one just for the example, and you save the data. And here you go back to your creation of mutant biomaterial. You add the regulated molecule and you put the name of the molecular tool you have just created. And the following steps are the same as I shown you just before. Go back to the article card. Okay. This we don't care. Okay. Let's go back to the article card. And here you will access to the free data, the free evidences you just have entered for the corresponding gene with the two inhibitors. And you can go back to the article. Here, just you have to also specify manually what molecular tool was used in the article. So here you enter again the molecular tool that was used in the article. You save data and you have the molecular tool that appear here. Okay. Okay, so you have also to specify manually in the article card the genes for which function was studied. So just to remind you what is regulation and function in ANISEED. So here, for example, you have a wild type expression of gene A, and in the evidence you disrupt gene X and you look at the expression of gene A. And in ANISEED we say gene A is studied for its regulation and gene X is studied for its function. So gene X should be also entered manually in the function field in the article card. So to do this, you use the target gene of molecular tools because these are genes that are studied for its function. So you will search for the target genes of the 2-molecular tool, and you will enter this gene in the gene functionally analyzed. Here, you take the second one, and you add here field here, and you save your data, and you okay, and the article card is now completed for this kind of evidences. And if you click on show enter experiment for the corresponding gene, you will access also to the corresponding evidences if there are more. Yes. Okay. So that's it for today. Thanks for watching, and don't hesitate if you have any question or if you have any remarks, and I'm here to answer your question. Bye bye.